Okay, anyway, let's start now. Now we're doing 3.6. We are looking at quadrilaterals. So quadrilaterals are a plane shape with four sides. Okay, you must remember. Quad means four, laterals means line. Okay, so you have four sides. Four interior angle. Interior angle means they are inside of the shape. So quadrilaterals are giving different names. Okay, so one quadrilateral can be another, but the other cannot be that one. So let me explain. For example, a parallelogram. Parallelogram is a shape where the opposite sides are parallel to each other. Both pairs of opposite sides are parallel to each other. Okay, they have different properties. You can see the diagonals bisect each other, means that they cut each other here, not at 90 degrees. However, if you look at the next shape or the next quadrilateral, look at rectangle. Rectangle is a shape that has four sides as well, and two pairs of sides that are equal and also parallel. You can see they share similar qualities. Okay, but to make it a rectangle, the angles inside, all the interior angles has to be 90 degrees. Cannot be anything else. It cannot look like this one here. This is not a rectangle. This is a rectangle. And this is also a parallelogram because opposite sides are parallel to each other and they are equal. You can read the first criteria here. They are the same. Okay. Next one is diagonals are equal. For rectangle, the diagonals are equal, but for parallelogram, no. You can see they don't have lines here. And then the diagonals bisect each other, they share the same quality here. All right, then we go to square. When we are looking at square, they do have similar qualities as well. For example, you can see this one here. All sides are equal. They are the same as this one. Opposite sides are equal. Okay, but they are all the sides are equal. And you can read diagonals, not diagonals, the opposite sides are also parallel to each other. So a square can also be called a parallelogram. But a parallelogram cannot be called a square. Understand? Because this one has the qualities here. Opposite sides are parallel to each other. Opposite sides are equal to each other. Diagonal bisects each other. And then, well, that's about it. Got three qualities only. Okay, so the rest you will know all angles are 90 degrees. The diagonals for this one are equal. So you can see they share similar qualities with rectangle. Okay, all angles are 90 degrees. You can see they share the same thing. Then we go to the next one. The next one is a rhombus. In other words, a parallelogram square, or I would say a slanted square. You can see a square is like it's being pushed because it shares similar qualities with the square as well. They have all sides are equal in length. You can see they are the same. Opposite sides are parallel. Well, you know here they are parallel already. Same thing here. They are parallelogram. Diagonal bisect each other at 90 degrees. You can see this one and this one. They are the same. Diagonal bisect angles. Opposite angles are equal. So all these things are fairly similar. So you can see this and this, they are the same. This and this, they are the same. Okay, next one. Okay, these two shapes are completely different. They are called trapezium. They only have certain qualities. For example, they only have one. For trapezium, opposite sides are parallel. This and this, they are parallel to each other. Okay, that's it, trapezium. And then we have a kite. Okay, a kite and a diamond is a different thing. A diamond is a rhombus. When you draw a diamond, you will draw it like that. That all the sides are equal when you draw a diamond. But when you draw a kite, it's different. The top has the same length, the bottom has the same length. All right? So this is a kite. is different from a rhombus. Although a rhombus, you tilt it, it looks like a kite, but it is not because all the sides are equal to each other. Okay? No matter how you draw your quadrilateral, no matter how odd your shape is, even if you draw like a really weird one like that, 1, 2, 3, 4. Oops. 1, 2, 3, 4. Even if you draw a shape that looks like this, it is still a quadrilateral, but it doesn't have a specific name for it because it's an odd shape. But all angles, all the interior angles add up together, they have the same value. All of them will add up to 360 degrees. No matter what odd shape you draw, even though you draw like that, it is still 360. Even if you draw like that, also still 360 when you add it up all together. All right. So you can see here, the angle sum of a quadrilateral is 360 because when you take one point, well, you can apply this technique to all shapes. You take one point, you join all the other vertices, you'll see how many triangles are there. When you join it in a quadrilateral, there will be only 2 triangles. So the sum is 360 degrees. You must remember this. Quadrilateral, any 4-sided shape, the total interior angle is 360 degrees. Must. Cannot be anything else. It must be this amount. So let's look at this one here. It says find the size mark in angles in each of these figures. So it's a parallelogram. You will know this and this opposite angles are the same. So this is 70. This is also 70. And then you also have learned co-interior angle when you have 2 parallel lines. What happens when you have 2 parallel lines? When you have 2 parallel lines, the angles inside adds up to 180. So 110 plus 70 is 180. So in order to find x, we're using the idea of 4 interior angles. 180 minus 70, we get 110. And then you know this is 110. The opposite is also 110. Only applicable to parallelogram. Next, we look at rectangle. Rectangle also add up to 360. Don't worry. So you can see here, this is 90. This is also 90. So when you see this Z thing, X will be here as well because what we call it, alternate angle. So we just need to find what this is. 180 minus 65 minus 90. We get 25. So this is 25. This is also 25. And then we have our alternate angle here as well. You can see this Z, Y, and 65. They are the same because they are parallel lines. Last one, an odd-shaped quadrilateral. You can see 1, 2, 3. Oh no, 1, 2, 3, 4. So first we need to find out what this angle is. So like I said, all quadrilateral they have 360 degrees. Take it minus this, minus this, minus this. You should get this answer here, which is what we call LKN. See? Answer is 65. So since this is 65, you have your, what do you call this thing again? Your isosceles triangle. This is 65. This will definitely be 65 without any question because they are equal length. So just take 180 minus 65, we get x here. That's our goal to find x, and we get 50. And that's about it. This is your exercise for today, 3.6. So, yep.